Hello there, and then welcome to a brand new video. This is how Beyond Numbers, where we learn maths the easy way. Now, in this playlist, we'll be looking at the BECE 2025 questions, and we'll try and solve all, and also give out some trial questions you can also use to test your understanding. So, without much ado, let's quickly look into it. This here is the first question. That is question 1a, and it says, given that P is multiples of 3, Q is positive numbers, and then they are subset of mu, which is x is such that our x is it's greater than 1, but then less than or equal to 20, where x is a counting number. And it says we have to list all the elements of P intersection Q. And then secondly, we have to list all the subsets of P intersection Q. So how do we go about this? To answer this question, you first of all have to list all the elements we have in our universal set. You see, to take note of the universal set. So then, talking of our universal set, it's something like this, right? And it's equal to, we want all counting numbers. When we say counting numbers, they are the numbers we actually use to count, you see. So our counting numbers start from 1, 2, 3, and then it goes on and on. But if you look at what we have here, it says they should be greater than 1. You see, it should be greater than 1. So even though counting numbers start from 1, because of the restriction we have here, we are not going to start from 1. But then we are going to start from the 2, 3, all the way to 20. So let me quickly write that. So this here will be all of it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. We are including 20 because of this sign over here. It says x should be less than or equal to. Had it said just less than, wouldn't have included the 20, but then we have the or equal to there, hence we need to include the 20. With that done, we can now go to the sets, you see. So we have our set P, and it says set P is multiples of 3, you see. So out of our universal set, we want to look at those that are multiples of what? 3. And we know our multiples of 3, so you can skip counting 3s, you see. So we have this 3 here, 6, 1, 2, 3, 9, 1, 2, 3, 12, 1, 2, 3, 15, 1, 2, 3, and then what? Your 18. Those are the multiples of 3. So we come here and then we write them out for P. So 3, 6, 9, 12, 15, and then finally your 18, right? Then it goes on to say Q are the positive even numbers. The positive what? Even numbers. Now, you know, when we talk of even numbers, they are also the multiples of 2, right? That is the numbers that 2 can divide without a remainder, exactly without a remainder. So for Q, we look for our multiples of 2, and then you have your 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20. So we write all of that out. So these are all that we need for P and then Q. You see, so the first question says we have to list the element of P intersection Q. We have to list what? The element of P intersection Q. When we talk of P intersection Q, intersection simply means what belongs to both sets. So we look at the set P and then we look at the set Q, and then we fish out the elements that are in both or that are common to them all. You see, so looking at it carefully, there is 3 here, but then we don't have 3 in this one, you see. So we just look at it critically to be able to determine the elements that are common to them. So there is 6 here, and there is also a 6 here, so we can get that for the intersection. Then there is 12 here, and then there's also 12 here, you see. So it is common to both. And finally, there is 18. There is also 18 over here. So for our P intersection Q, we come and list that out as 6, 12, and then 18. We are done with that. You see. Now the second question, which says you should list all the subsets of P intersection Q. That is where it's a little bit tricky. So let's look at how we will do that. So we know our P intersection Q, which we just did, was 6, 12, and 18. You see, so if you want to know how many subsets this set has, you see, the total number of subsets is given by the formula 2 raised to the power n. And I've done tutorials on all of this. You can go to the new numbers playlist and then you'd get all of this comprehensively. You see, so the total number of subsets given by 2 raised to the power n, where your n is the number of elements in the set. You see, so if you look at the elements we have over here, there are 3. So this simply means that we are going to get 2 raised to the power 3 elements as the subset. And 2 raised to the power 3 is just 2 times 2 times 2. That gives us an 8. You see, so we want a total of what? 8 elements. Now let's start listing out these subsets. Now the simplest one, or the very first one we can get, is the empty set, because we know the empty set is the subset of every set. You see, use either that sign or this over here. So we have our empty set, and then you now come and list out the individual sets. So 6, 12, and 18. You see, so the set 6, then we have 12, then we have our 18, and then we now start pairing them. So 6 and 12, then you take 6 and 18, then 12 and 18 as well. So we come here and then let's write that out. So 6 and 12, then 6 and 18, and then finally we have 12 and then 18 as well. You see, now we are expecting 8 elements. So far we have 1, 2, 3, 4, 5, 6, 7. You see, then the last one, we say every set is a subset of itself. So as we have listed all of this, we would include this set, that is 6, 12, 18, and that completes our what? 8. You get it? So this is basically the first question that came in this 2025 BECE, and I do hope you can do it if you were to be there. I'll leave some examples you can try on just to test your understanding. So at this moment, you can pause the video and then just look at these 3 questions. That will just test your understanding on what we've just done. See you in our next session. And in the next session, we'll be solving this question here, which was the 1B of the BECE question. Stay safe and then bye for now.